Okay, welcome everyone to the inaugural episode of Blueprints from the tinyML Foundation. This is a show that is, it's not necessarily about AI models or data sets or semiconductors per se, but it's about solutions. And I'm your host, Pete Bernard, and we may have Davis Sawyer from NXP join us shortly. But today we have three guests. We're going to talk about a really interesting problem around pedestrian safety. That's the problem, the topic of the day. And we're going to look at what the issue is and then how Edge AI and tinyML and technology can help solve that. So pretty excited to have three really important guests on the show today. We're going to have Leon Liu from Leopard Imaging, Yu Kitamura from Sony Semiconductor, and Ho Nguyen from the city of San Jose. And this is a live stream show. So whether you're watching this on LinkedIn or YouTube or Twitch, you can send us your comments and questions, and we will move along here. Someone is saying they can't hear me. Okay, so let's just see how that works. Hold on for a second. No, that should work fine. Anyone else not hearing me? I'm just trying to double check on that. Okay. We're going to keep moving on here, and if someone else can't hear me, let me know. Oh, we can hear now. Okay, good. All right. There you go. Live streaming. We love it. Okay, so we're going to bring on our guests, and let's bring on Yu Kitamura first, and you from Sony. Thank you very much. And you, where are you dialing in from today?
From Seattle, Washington State.
Right down the streets. I'm in Bellevue, Washington. So good.
Yes.
Excellent. And then we have Ho Nguyen from the city of San Jose. Greetings.
Greetings. Good morning.
I assume you're calling from San Jose. That's going to sell that.
I am calling from San Jose. Yes.
I would say if you're calling from Los Angeles, it'd be like, I don't really understand how that works. But okay. And then, of course, Leon Liu from Leopard Imaging.
Hello, hi everyone.
Hey, good to see you. Good
calling
to see
from
you. Fremont, California. Okay,
Yeah.
so this is definitely a West Coast-based contingent here. But, you know, pedestrian safety obviously is kind of a worldwide issue. And this was just a fascinating topic. You know, we have a lot of folks in the foundation building a lot of tech, a lot of cool chips and a lot of cool software and devices. But, you know, we thought it would be interesting to kind of flip this a little bit and talk about some of the key problems that are happening around society and different industries, and then kind of work our way backward to the tech. And so that's what this show is all about. So I appreciate all of you here. And so what we're going to do is we're going to work our way backward. We're going to start with what is the issue here around pedestrian safety, and have Ho kind of educate us on that. And again, live Q&A. So if you have some questions, we may pop them up real time. We may bundle them together, depending on what they are. And then after that, we're going to have Yu Kitamura talk from Sony. Is that right? Is that next? And then Leon at the end talking about the thing, the camera. Pretty exciting. Cool. All right. So why don't we get started? Ho, why don't you get started? I'm going to bring up your slides and give you the floor, as they say, and kind of let you do it. And the rest of us we'll just kind of hang off to the side here as you do your thing. How's that sound?
All right. Sounds good. Thanks, Pete. All right. Thanks for that brief introduction there. So again, my name is Ho Nguyen. I am the manager for the Intelligent Transportation Group here at the City of San Jose, Department of Transportation. I've been here with the city for about 26 years. So just a little quick background before I get into the details of the proposed technology and project. I was engaged by tinyML about a year ago, and the organization approached us wanting to see if we were interested in being one of the judges for a hackathon event. They proposed a challenge back then, and that was to they had this of course, tinyML is an organization that develops edge-based AI. They approached us, we have this technology. What can San Jose do to leverage this technology? So I, with my colleague here in San Jose, we kind of brainstorming what we wanted to do with this really cool technology out there. So I partnered up with a gentleman here in San Jose who oversees the Division 0 program. And For those who for those who don't know what Vision Zero is, it's basically a worldwide initiative that aims to eliminate traffic fatalities and severe injuries, while at the same time, increasing safety, health, and equitable mobility for all. It's basically an attempt to reduce fatalities to zero. That's why it's called Vision Zero. It's a very noble attempt, and it was started back in Sweden back in the early 1990s. It only came over to the U.S. I think about 10 years ago, so it's been very recent. As a matter of fact, San Jose only formed the working group last year to focus on this particular initiative. So it's a very recent thing here in San Jose, but the timing was perfect. tinyML approached us, asking us to be one of the judges. We agreed, and the result of that hackathon was Sony that had this particular technology already in place, and it was really cool. And and this is really the reason why I wanted to talk about this. I was invited to talk about this particular technology. But just briefly, what the Vision Zero is in San Jose. Our program, again, kind of focused on reducing fatalities. And down there, you just see a quick graph that shows, within the last 12 years or so, our fatalities, traffic fatalities, actually doubled. And that is not a good trend to see for anyone, obviously. So, so obviously we have a focus to reduce that down to zero. So we're going to try everything we can to do that. And I think tinyML and the technology that it promotes, is perfectly aligned with what we want to do here at the city. Okay, so that's just a quick disclaimer on my part. But let's talk about the city and what we see as a challenge in this particular space. Of course, there's challenges everywhere else. Within the city, we're a large city of 1 million people, so obviously there's a lot of challenges. But the challenge that I think that the Sony technology can help us address are the three that I list here. Okay, and first of all, right now in the ITS market, which is the space that I work in, there's a lack of scalable and cost-effective, reliable, and automated data collection system. There are data collection systems out there that are, very manual, like traffic counts, for example. We have human beings that go out there and put these tubes on the road. I think we're all familiar with those. The newer ways of doing it is to mount cameras on a pole and then just run a recording over a period of a week or so, and then do post-processing on the recording. That effort can easily cost $2,000, and as you can see, the recording is done only over a period of 1 week or so, done during the peak hours, very specific times, because there's a lot of human factors involved in that, right? So there's a like an automated way of doing it. So that's number one. Number two, there's also a lack of scalable and, again, cost-effective real-time safety analytics. With the advent of Vision Zero initiatives, popping up throughout the country, there's really no solution right now to automatically capture safety analytics, safety measures, right, at signalized intersections, and more importantly, at non-signalized intersections. There's a lot of reasons why we as traffic professionals want to capture safety measures, safety analytics at non-signalized intersections, at stop sign locations, at mid blocks, right?
Crosswalks.
Crosswalks.
I had a quick question on that. So when you say safety analytics, like what would be examples of data that you collect?
So the kinds of safety analytics we're talking about are basically speeding. Number one, speeding is a primary concern when it comes to Vision Zero. Okay, speeding. Volume of cars, how many cars are traveling through this particular crosswalk or intersections? Is it a prime candidate to convert a non-signalized intersection to a signalized intersection, right? Are people crossing outside of the crosswalk, right? That's a huge concern for us. So these are safety analytics, and right now there's really no proven way of automatically doing that on a real-time basis. There are solutions that uses cameras and AI, but a lot of those are based on post-processing. Okay, there's no on-demand, impromptu way of doing that. And lastly, and this is probably applied to the entire city as a whole, not just for DOT, is there's no scalable AI-based IoT devices that I'm aware of that has, AI capability. There are basic, traditional IoT sensors that turn on and off certain things, but not with the kind of, logic that AI can provide. Okay. So we don't see that right now. I don't see it. Now, I don't work in the IoT space, so I have very limited knowledge of it. But the ones that I'm aware of, I'm just not aware.
I'm sure folks are working on it, but
yeah. I hope so too. And I think the Sony solution is very close to achieving that. Right, it's an IoT device. It has AI capability and it's edge-based processing, so it has a lot of promise. And and I'm looking at these IoT devices to contribute to the smart city initiatives. I'm pretty sure we all heard of smart city, from applications that run in the background to devices that you see on the field. So we're talking about devices such as surveillance cameras, curb management. This is beyond what I do. So these are very relevant challenges within any city, right? Trying to see what's happening at the curb so that we can better manage the curb space, and then surveil areas that needs to be looked at. Like for instance, pool boxes. There's a rash of incidences where we have vandals coming into our pool boxes, cutting our cables, thinking that they were copper. And
what is the pool box, by the way? Is that for like
a pool box? Is a box in the ground where it provides access to cables. Okay.
Okay.
Yeah. So this is where we run our communication cables through, our streetlight cables, our signal conductors, and believe it or not, within the last month alone, we had 3 or 4 hits in our communications cable. People coming in, thinking our fiber was copper, okay, and they would cut our fiber cable, and you know how much effort it is to restore the communications. So it's a big annoying thing for us, and we don't have any kind of technology that can address that.
I was going to ask, I think one of the things I'd heard, I mean, we talked about the cable issue, and I know that there's a lot more innovation happening in wireless communication and wireless networking. And one of the big challenges also with a lot of the deployments here is cost, right? Is the complexity and cost of deploying solutions. I had heard somewhere where like the typical cost to just open a manhole cover somewhere is like $50,000 or something by the time you get the crew out there and all this other stuff. So I think is one of the things you're looking to is like, how do we deploy this stuff with like a reasonable cost, and also, maybe wireless is better in all cases because of these.
Oh, definitely. Cost is a huge factor, especially when it comes to IoT devices. IoT devices are meant to be installed in large quantities, right?
Yeah.
There's no point in installing one IoT device at one location,
right?
Or just a handful, right? You wanted to envelop the entire city for any particular application, right? And that's how I approach it. You want it to be cost effective, and that's one of the few things that I will talk about later on as a system requirement. Why we're looking at the Sony product.
Right.
Okay, so some of the use cases. So I talked about the challenges already. These are some of these specific use cases that I want to address. How I think the Sony system can benefit us. In particular, we're talking about data collection. Data collection is a huge thing here in DOT specifically. We do specifically turning movement counts. So these are basically counts of vehicles, of pedestrians and bikes through an area. It doesn't have to be a signalized intersection. That's key here, right? It doesn't have to be a signalized intersection. It can be just a regular stop sign location.
Side street, whatever, yeah.
Side street. It can be mid-block, okay, to capture annual daily traffic, which we call ADT. It can capture speed, vehicle classification. Now, of course, we want to be reliable. We want to achieve an accuracy of at least 95%, okay? Traditional manual counts, with human beings out there, they can, at best achieve 95%. No one can do 100%. So we're aiming for at least 95%. And within these categories, these are, more specific examples of data collection that I show here in the slide. Some really interesting one that I think the Sony system can do is, in addition to the turning counts and things like that, which a lot of other technology can provide, I think what AI can provide is like, for example, detecting how long a car waits at an intersection, okay, or the length or the queue length of cars when it has to wait at a stop sign or at a stoplight. Those are all very, very important data that we as engineers can take in and fine tune our signal timing. Okay, so it's very, very relevant data, and I think systems like the Sony system can provide that kind of data. Next thing here, safety analytics. This is something I kind of touched on earlier.
By the way, just to go back to your other thing,
Mhm.
for those familiar with quick serve restaurants, a lot of the data you're looking at here is similar to a lot of retail as well, like dwell time,
Oh, yes.
waiting to be served,
Correct.
a quantity of cars in the parking lot, flow of traffic. So a lot of these kinds of solutions that can be applied to critical infrastructure in smart city could also be applied to other environments like retail as well. So
Exactly. So the other use case I had mentioned earlier was the safety analytics. So in DOT in particular, we want to see analytics that support our Vision Zero studies and implementations. So after we conduct our studies, then we have to use that data to then form countermeasures, right? What are we going to do to make things better, right? So this is just an example of what of what we would do, say, at a signalized intersection. Now, this is signalized. It can be also a non-signalized intersection. We have crosswalks. We have people crossing the crosswalk. We want to count how many pedestrians crossing, right, so that we can, maybe turn an uncontrolled crosswalk into a controlled crosswalk. Put lights up, right? Put flashing beacons up. We want to know how many bicyclists, are traveling through an area so that we can install bike lanes. Or what kind of users are there? People on bicycles or mopeds or scooters, things like that. We want to know that. The vehicle types. Okay. Now with Vision Zero, there are 5 pillars within the Vision Zero initiative, and with this particular technology from Sony, I think we're primarily focused on the safe road users, right? On the safe speeds, okay, and the safe roads. Okay, so these are the 3 categories that I think the Sony technology can really help us focus on. And lastly, the one really cool thing that I want to talk about is near misses. Okay, it's a something that was recently okay, so along with Vision Zero initiatives, there's been an increase, focus on. It's great to have all this data, right? But then, can you provide like additional insights? How did this particular accident happen? Right. So if we can capture the data before the accident happens, it would help us better understand, what caused this particular near miss, right? So there are systems right now that are beginning to develop capabilities to provide their predictions for near misses, right? And I think, when you incorporate AI into a vision-based camera, you have the potential. And I'm not saying that we're there yet. I've seen solutions out there that attempt to do this, and right now they're doing about 10% accuracy. I mean, obviously, I want to get that number up to 50, 60, 70% if possible, right? So having the ability to see near misses at an intersection is really, really nice.
Do you have the ability to, maybe this is a question for Leon, to detect if someone's looking at their phone when they're driving? That might be that'd probably be close to these things.
That would be sweet.
Yeah, technically it's possible. Yeah, with the AI building, there's a lot of possibilities, and there's models we can train and tackle this problem.
By the way, there is a question that came up from Mark Wilcox. Let me just throw it on the screen. Sure. Can you cite specific initiatives within the San Jose 2020-2025 budget targeting improvement or new developments in ITS deployment? So pretty specific question, but
in 2024-25, so there's no specific initiatives within ITS. There are initiatives in DOT as a whole, okay, that implements all kind of measures, all kind of projects, but specific in ITS deployment, this particular fiscal year, no. In previous fiscal year, we've set aside millions of dollars to expand our communication infrastructure. We do have ongoing budget to install detection cameras. Okay, and although that's not exactly the same as what we've seen here with Sony technology here, but it is close. You know, we are deploying cameras that detect vehicles to actuate signals. But for this particular fiscal year, no. I have in previous last year, I did attempt to send in an application for a SMART grant, for a federal grant called SMART, and that was to promote. That grant was meant to promote pilot projects, looking at new technologies, and this was perfect. Okay, but for some reason, the Fed. I scored very close. San Jose scored very close, but we didn't make it. Okay. Hopefully, you know, we'll have another shot at it. You know, when I went, I think we went to AITRIOS California a few weeks ago, and I'm very happy to see that AI is becoming to be more of a focus within ITS. Believe it or not, I know that it sounds kind of funny. You know, here in ITS, it takes a while for technology to reach us. Believe it or not, we're not on the cutting edge of technology. But I'm beginning to see, you know, people are more interested in AI. In particular, there was a very specific example on near miss. Companies are adding near miss capabilities into their product, and traffic professionals are just now starting to assess those capabilities. All right. The last use case I want to talk about is again having IoT sensors with smarts and logic to it, right? Not just plain on off anymore, but having AI capabilities. And you know, I use the example of curbside management, right? And basically, curbside management, you know, seeks to inventory, optimize, and allocate and manage space, right, to maximize mobility, the safety and access for a wide variety of demands. Okay, so you can see with the introduction of Lyft and Uber services, retail expanding, the curb space is beginning to be looked at, you know, not just a simple space where you park your vehicles next to it and then, you know, when pedestrians walking, but, you know, you're using for other purposes, just lift, you know, drop off, pick up, things like that. And then street side surveillance. And I'm talking specifically about, you know, surveilling vandalism, right? Now, I don't think this is an application, real-time application for people, you know, surveilling people for crime or things like that. I don't think this is what it's for. This is to surveil vandalism and then act on it in some way or fashion. And that's just some pictures of, you know, this is a picture of a recent cut of a fiber right there. That just happened about two weeks ago, I think. So specifically, what are the requirements that we want to see in a solution, IoT-based solution that has AI capability? First of all, it has to be weatherized. You know, this is an outdoor unit. It's going to be installed outside. It needs to withstand up to 65 degrees Celsius. That's number one. Okay. Number two, I'm envisioning these kind of equipment to be installed everywhere throughout the city, or having the capability to install everywhere throughout the city. And what's the most obvious infrastructure where this item is going to be installed on poles, right? On specifically streetlight poles. We have streetlight poles everywhere. Okay, pretty much every 500 feet there's going to be a streetlight pole. So that's the most obvious location, and it's going to be installed, you know, 25 or 35 feet above the ground. And then, you know, as far as looking out, we want to look out as far as possible, being able to see out as far as possible, so that you can see vandals happening on sidewalks, right? That's a key. And then obviously it has to operate at night. I think that's a key here. When you want to put capture analytics, particularly for pedestrians, the nighttime traffic fatalities happen at a much higher rate than during the daytime, for obvious reasons. I think I don't need to show you the numbers, but if you crank the numbers, you will see that nighttime fatalities easily double the number of daytime fatalities. So the system has to work well under ambient light, which is basically light underneath the street light. Okay.
Yeah.
Power. Now, fortunately, we have these street light poles are powered by 20 or to 240 volt power. But the intent here is that because they're low powered, I'm hoping that these devices can also be powered by solar panels, by batteries, that can run up to 3 days without sunlight. Okay. What I mean by sunlight is that on a cloudy day, right? So 3 straight days of clouds. Okay, I think that's a good threshold.
We have that a lot here in Bellevue, Washington. 3 straight
You
days.
guys probably have more than 3 days. And the communication. Okay, now it has to communicate to the internet, to the cloud, and the best way to do this is through cellular, in my opinion.
Yeah.
And there's no, although the city maintains our own communication infrastructure, we have fiber. There's limited space and reach in how much the city can do. Right. We're not, we're not an AT&T. We're not going to install fiber cable to every single home.
Well, and to your point about the vandalism, it just adds more risk to the whole infrastructure.
Exactly. Yeah. So it has to communicate via wirelessly to the internet cloud. And then API. Okay, having the ability to support third-party application is very critical. I see the Sony as an IoT device, as a hardware device. Whether it provides an interface that is usable to everybody or not, that's a subject that can be debated at a later time. But every agency will have their own, data system already, big data system.
Sure.
Big data platform. As a matter of fact, San Jose just went through an RFP and selected one about a few weeks ago. So there is currently, we've already selected a big data platform here at DOT. I don't know what that name is yet, but the idea is that, to integrate, this Sony system into that data, into that big data platform, okay, through an API. Relay contacts. This is kind of sound backwards, but there's a lot of things that can happen locally. We can use the IoT device to trigger another device locally at the intersection. You can trigger it through Ethernet, or you can trigger it through just server-based communication, or even just relay contacts. Relay contacts is the lowest common denominator used in traffic. There's still a lot of equipment that still uses relay contacts, and this is not a strict requirement, but it'd be nice to have. Okay. And then the last item I really want to talk about is the low cost. Okay. It has to be low cost to deploy, to operate, and maintain. Those are key, because if you're going to install this, at hundreds and thousands of locations throughout the city, you definitely need it to be low cost, right? Easy to maintain. And yeah. So I think that's obvious.
Well, I think there was a question from Mark around budget. I mean, budget is always an issue. And so the more functionality you can squeeze into these shrinking budgets, probably the better. So
yes. Okay. So I think that's all I have.
That's awesome. I wanted to, by the way, welcome Davis Sawyer from NXP, who joined us. He's at the bottom square there.
Thank you, Pete.
Awesome to have you, Davis. And no, that was really good. There's a couple of more questions here. I'm not sure. This one from Mark, we can punt it as we get more technical, but he brought up a question around using LiDAR for pedestrian safety solutions. Maybe that's more of a Leon question, but is that something that's been trialed, or?
It's actually currently being trialed right now in San Jose. We've had a system for at least a year now. It was an old generation system. We are now looking at their latest generation system that is solid state LiDAR. So we will have 2 locations running LiDARs. So we are actively looking at that. LiDAR is a different beast, though. I don't see LiDAR as an IoT device. Cost is still very, very high. So I don't envision, deploying LiDAR in mass throughout the city. However, it has its place, at signalized intersection, and that's where I'm piloting those devices right now.
Yeah, cool. Well, good. I think next up, and by the way, keep the questions coming. That kind of helps everyone that's watching this too. I think you, Kitamura from Sony, do you want to go next here? And I can bring your slides up.
Can you start from the...
Yeah, back to 1. How's that sound?
Yes, so thank you. So hello, everyone. Good morning, good evening, good afternoon. I'm Yuki Tamura, Business Development Manager in Sony, particularly for the smart AI solutions, Edge AI solutions. Next page, please.
Okay.
Well, who is Sony here? We are having this different type of the business, including all the electronics, pictures, and then movies and music, PlayStations. What we are doing here is the semiconductor. In fact, actually, we are the largest, one of the semiconductor type called image sensor company in the world, which is used for the different type of the digital camera. This is the semiconductor. It's an eye for any type of the digital cameras, converting the optical signal to the digital for the digital the imaging. So this core device image sensor is used for your smartphone or security cameras we talk about, the IoT, the factory automation camera, medical endoscopy. All these digital camera has image sensors. And Sony has been developing this for the last actually 50 years, long time now in history. And we are always the number 1 market share and then leading the technology in this space. So that's who we are. Next page,
Sounds
please.
good.
So the whole talk about all this, what he is looking for as a use cases, what's the solution requirements. Just to summarize, I think we rely on a lot of the manual or some selected the technology use, which limited city use the data because it's a limited sampling point of the geographically and temporally. Now he's looking for the more automated data collection at scale, which gives some additional data for the cities for their optimized decision making using the permanent based data. And hence the citywide coverage, the data. So that's our understanding. Next page, please.
That's good.
So, quick question, along those lines. You guys are the technology leader in the space, but as Ho mentioned earlier, ITS was typically slow to adopt AI, and so it's great to see this use here. But can you talk quickly about how this collaboration got started? I mean, and it's kind of set the stage for how you got those requirements. You have the technology, they have the need. How did this kind of come together? I think it'd be interesting for everyone.
Yes. So I think I say this is the perfect questions for today's lineup because we are developing a semiconductor. Now, semiconductor itself, it cannot do anything for the end use, right? So we developed this technology, but we are actually working closely with the partners who bring the solution to the market. And as one of the company here in the Leopard Imaging is the company who developed the solutions for the end use, and particularly for the smart city use this time. So that's something we are working on. So we developed the technology already, but we are in the stage of developing the solution together with a partner to bring to the market.
Right.
So the technology here is I said the semiconductor is the eye for digital cameras. What we develop here is the eye and brain combined into one semiconductor chip, which is here IMX500 as image sensors. This is the industry first AI-enabled image sensors, helping people to develop the cameras, AI cameras at low profile, low power consumptions, and then at the affordable cost for the scalability. So that's the technology we just developed, and together with the management cloud services, we are rolling out to the market with the partners. It has the characteristics of the Edge AI, the benefits. Such as the low bandwidth use or the power consumption use because it's semiconductor chip solutions. Now, this is not the same as the high horsepower GPU, the processors. Well, we are living in the tinyML space here. So
this is not a 1200 watt NVIDIA Blackwell chip.
Exactly. Yeah, but it has the capability to do the certain job, which I'm going to show you the video clips later And then the privacy. So the public use, the people are concerned about the privacies. So this system, it can be used as sensors, data collection sensor systems. You can collect the image and data, the videos, but also they say you can have the choice not to collect the data, because this is going to be the personal identifiable informations. And then once you have it, you need to manage it in a secure ways to prevent the privacy erosions, which is actually a high burden for a lot of the project. So this will give you the choice for not using the privacy identifiable informations.
That's actually a big value prop of edge AI in general, right? Is you're running the AI workloads where the data is created. I call it AI in the real world. That's kind of what this is all about. And someone had mentioned, I think Ang had mentioned here, models used edge or cloud running. I think what we're talking about here is primarily the AI models are really running on the edge in the device itself. And then the metadata, the results of those kind of models are then being uploaded to the cloud, which are then, anonymized, obviously, because it's just the metadata. And then the cloud can run its own analytics, like time series insights and things over time. But one of the big benefits of tinyML, edge AI, whatever you want to call it, is that this stuff is happening when the data is collected in a much more private way.
And Pete, I think that before we go to the next slide, because I think this is the perfect slide to another question we got from Alex. Pete, if you want to maybe pull it up, because it's also about why the edge.
Sure.
I mean, it's the cost might be cheaper in the short term to do a few samples uploaded to a cloud, but in the long run, edge scales much nicely for the reasons that we all just described, right? You have that differential offloading of data and results. Cloud can store things long term if you need that, but I think that edge scales better. Also, there's non-economic incentives like privacy, which is a big one. So I wanted to highlight that because this slide answers those questions, I think, nicely.
Yeah, definitely.
So and I would add here also, if this was done as a cloud-based solution, that implies that you have to send the video over your cellular connection to the cloud. Sending video over cellular is extremely cost prohibitive. Okay, extremely cost prohibitive. So having the processing done at the AI and only sending metadata to the cloud is the perfect solution to scale. Okay, so I think for us that's a good point.
Yeah, I want to add that with the edge device, the response time is even faster because it processes the data locally, and also we already addressed like the privacy issue, a data bandwidth issue. I'll talk more in my slides.
Yeah, cool.
Okay, next please.
Next.
So this illustrates conventional system. Okay, people use the security IP cameras and then having this the GPU appliance at the edge. This is also the edge AI system, but this involves multiple other equipment at the site, which you need to manage and maintain. Now, our system is with the Leopard Imaging. It's one AI camera at the site. Simple is the best, and giving you this the oldest variety of the use cases with easy deployment, lower power consumptions, privacies protected, and then affordable costs. I think Leon is talking about more about this easies and low powers and things. Next page, please. So these are some of the use cases can be supported. So traffic management, traffic counting is one of the things that which Paul talks about. The parking management, curb space management is another thing. Dynamic lighting based on the presence of the pedestrians and vehicles. You can control the section of the lighting to dim up, for example. The crowd management, if there is a big sports event or the concert in a town, then you can you need to sort out all this pedestrian traffics and things. So traffic officer need real-time information of how to handle this crowd. The road surface, the snows or the floods and those kind of things is something the city needs to respond to close, and then they set the diversions and things. And then there's a lot of the road safety, which Ho talks about, how to protect this vulnerable road users, pedestrians, bike, and those of the people they're from the fatality. And then the beauty of this thing, this is an open AI platform, so you can join to develop the application together. together. So anybody who have the skill to develop these AI models, you can develop your AI models, deploy to these platforms, and then they develop this application together to improve the society.
Just a quick distinction. When you say OpenAI, you mean two words, not the one word is in the company. You mean it's open
Yeah,
AI,
not that
not
OpenAI.
the,
You mean-
not,
It's not
we don't.
OpenAI as a company.
Okay.
Being open.
Not
Yeah.
one word.
The original
Good, good.
OpenAI.
Right. There was,
Yeah.
okay, thank you.
That's a good point. That's a good point, David. Thank you.
All right.
So this is the example of the pedestrian, the detections and traffic counting video clips. So the Pete, maybe you can.
Yeah,
switch
sure.
to- So this is the pedestrian detections. You can see these people jaywalking here and there actually. So this city has a challenge of this the
Gives me
jaywalking.
anxiety just watching that. Yeah,
I know.
It's
Yeah.
stressful.
Pedestrians, fatality. Actually, this 1.5 mile sections, the 90% of this pedestrian fatality happens in this section because this is a state highway. The traffic is high speed, and then there's one side is that there's a lot of motels. The other side is a lot of the smoke shop, liquor shop, convenience retail stores and things. And then it's actually there is the crosswalking just below at the edge of this the video here, but nobody is going to this.
Nobody wants to walk the 20 feet to.
Yeah. So the city tried to implement the pedestrian detection system, giving the LED warning to the drivers to reduce the fatality possibility. So that's what the city challenged. And then they are evaluating all these pedestrian detection sensors, including the LiDAR, video systems, and then our systems. And then with under the different scenarios and the weather conditions, the lighting conditions. So you can see these videos, they giving you the detection capability of the bright sky days, night times, the rains, and backlights. Actually, this is the east-west road, so this the sunrise. You will have a strong backlight. Now, this based on the evaluation criteria city defines. And picking up the sampling data of the 3 days of the recording, as well as city-defined use case-based behavior scenario testing. This solution achieved 100% of accuracy, actually, to detect the pedestrian in reliable manners. Of course, this is sampling of 3 days. Okay, you are doing all this video manually tagging as the proof. So you cannot do this 365 days of the recording with that, but it's based on the.
It's a good POC, yeah. More than that, yeah.
Exactly. This is a POCs, how you evaluate, how you they set the goals and those kind of things. So that's one of the example.
Mm-hmm.
The next video is the traffic counting. So this is another use cases, traffic counting. So this just counting this the driving through the road and the drive turning right of the road, drive turning left of the roads, and then the counting accuracy again actually based on this 3 days and sampling of the times of the counting, it achieves actually 100%. So over 95% of the accuracy is achieved here.
So it'd be cool if you had a red square around everyone who's looking at their phone while they're driving, and then the green is just driving normally. Right?
Yeah, that's Leon's job.
Yeah. For this, I want to add that if you back to the you don't need to back to the earlier video. That actually you can see that with the edge device, it's capable of detecting the person, the cars instantly. So if we transmit the video to the cloud and it will take a while and then process and come
You've
back.
already crossed the street.
Yeah, across the street.
Yeah.
Right. So I want to point out this is a good example to address the question, answer the question just now.
And actually, as Hose mentioned, relay out. All right, this is not a new technology. This has been in the market for the last 30 years, probably.
Yeah.
But that's the most reliable way for the immediate, the real-time action to the other devices, such as the traffic control lines and things. Yeah.
That's awesome. But before we move on to Leon, there was a question that came in from Mark for you. How many? I don't know if you know exactly, but ongoing POCs are in the U.S. and the applications that are most popular, and then what's the balance in Japan? If you know, if there's is the U.S. sort of like the place where this is all happening, or is the U.S. lagging relative to other factories?
Well, the Sony is a Japanese manufacturer of the technology. So we start with some of the Japanese markets, some of the POC things, and then now rolling out to the US market. We are working on some of the POC project in US. Not only the smart city things, but also the other the use cases such as retail, logistics. There is a lot of the use cases application which this edge AI solution can help to automate this process.
Right. I think that question is actually at the heart of the blueprints. I know we didn't cover maybe at the beginning what a lot of the motivation for this was, but it's actually the heart of the idea, right? Is that this success can be replicable with some modifications to other environments. And so while you have the trailblazers on this call, the idea is that this technology and solution will penetrate to more geographies, areas, applications.
Right. Use cases, yeah. Sounds good.
All right. So
Excellent.
I think that's the things, and then the back to the slides, and then just a quick go through the last point.
Sorry.
We are so this how to achieve the scalability of the deployment. Okay, obviously the total cost of ownership is really the important, and it's a lot of the cases we see that now, particularly in US, installations, maintenance, those kind of the costs actually cost more than product equipment and costs. And then how to minimize this installation maintenance is the real key factor for the scalable deployment, as well as obviously product itself needs to be affordable cost. Now, the big component of the installation is the network installations and power installations. So how to manage these things is the key, which I think Leon is trying to address this point. So that's the last point, and then they hand it over to Leon.
Awesome. Thank you very much. Yeah, Leon, let's get into the actual cool stuff that you guys are building.
All right.
Solving this problem.
Oh, okay. Yep. Here's the fun part. Everyone, thank you for joining us today. My name is Leon. I'm the co-founder and CTO of Leopard Imaging, based in Silicon Valley. Today, I'm very excited to introduce a groundbreaking smart city solution that addresses many of these challenges cities face today. On this slide, I listed some of the key issues we identify from the systems point of view. So our solutions directly tackle all these challenges. Many of these challenges are already mentioned, but some of these look trivial, but it turns out it's not trivial. Just as, for example, installation and maintenance cost. Installation, a camera or other devices on a streetlight pole or traffic light pole or the building can be costly. It's much more expensive than what we thought, and requiring skilled technicians. If it's not designed well, it takes a very long time to install, and when you adjust it, it becomes very difficult. So to address this, we've designed our system with ease of installation in mind, aiming to minimize the time and duration and make sure it's easy to install. And some of these already talk about connectivity limitations. We already mentioned cloud-based system and edge-based device. What's the big difference is that for a cloud-based, you need to rely on constant, relatively high-speed network connection. And also the data rate, talking about when you scale up, the data would be huge. You transmit thousands or even tens of thousands camera. Thinking about the video streaming through the network, the data is huge. Let alone if you want to store this data on the cloud, that will be a big problem. On the other hand, the edge device.
Hey Leon, I have an actual number for you.
Yep.
So we have one camera that is sending video 24/7.
Yeah.
Over the cloud. In 1 month, it's 2 terabytes.
Yeah. Yeah.
2 terabytes.
Right. Yeah.
One camera.
Yeah.
One camera.
Sure. Yeah. If you talk about hundreds cameras, thousands cameras.
Yeah.
What would be the data? So. Yeah. Right. So with this technology, with Sony's technology, NXP technology, we are able to make this beautiful edge device process on the edge. You don't really need to transmit the video only just me the metadata or the test result. In the meantime, we talk about scalability. This is, I think, it's almost like number one issue we want to tackle. So the high cost, particularly in build of material and including the power consumption, a lot of costs, including if you use a generic GPU based or CPU based, the cost will be very high, and scalability will not be possible, or it's very difficult. I think we already talked about the privacy. Yeah, privacy as well. Like the video is not transmitted out of the device. So what we see is just events from the device. Saying here's a pedestrian cross the street. You may not necessarily know who will be or what's the face look like, because this is a big concern of the citizens. In this solution, we only transmit the events.
Right. By the way, there's a question here from David around, can I go to a model zoo somewhere and get some publicly available kind of traffic counting models? I guess the answer is yes. I'm not sure exactly where to point to, but do you know about that? And also, can the data be stored on the device and downloaded periodically rather than requiring an internet connection? So can it really work in a truly offline mode?
So the first question, I take this. The second question, I leave to Leon.
Okay.
So the first question here is I think there is not really the public available traffic counting model as it is as achieving this good accuracy, obviously. I think there is some the public available models such as YOLO, which you can use as a base, and then you can retrain, and then also you can. I think that's key here is not only the AI model itself, but also like some post processing. The filtering all this result of the AI models, and then managing to get removing this false alarms and things. That is I think one of the key point to achieve overall accuracy. So that's more done to the people's work to achieve that. Yeah.
Sounds good.
Yeah, let me answer the second question. Yes, the device will have a local storage from 128 gigabyte to 1 terabyte. So it's possible then you can store a lot of data on the device. And with a network connection, we provide a variety of connectivities like LTE, Wi-Fi, Ethernet. So you can download the data periodically locally. Yeah.
LoRaWAN, I'm sure, stuff like that. So. Cool. All right, let's carry on.
Yep. So next slide, I'll go quickly. Now you can see there's this beautiful device. I'm happy to announce that we are going to release this product at the end of October this year. I'm very grateful that this is actually coming from tinyML contest last year, 2023. It's a pedestrian detection contest. And Leopard Imaging was very proud to be like the winner of this. And based on that, actually, so we designed this camera, so roll out this system. And this system integrated like advanced technology from Sony, NXP, and of course with Leopard Imaging's expertise in this smart camera design field. As I mentioned, it's an edge device. So the AI models can be loaded to this device, and it's very flexible. We've already tried many models. Something that I want to talk about is like model is not a problem. If you want to use this device very well, get a high accuracy, the data, the training, it's actually the key.
Yeah, I was going to say probably the data set here is probably one of the most important things, is having a good, clean data set.
Yes.
You know, without that, it really doesn't matter how good the model is.
Exactly. Yeah. Yeah. This is the all-in-one edge AI solution for smart city. Again, it's from tinyML Hexagon. We expected this time. I highlighted there are three advantages of this solution, like optimized performance, inbuilt the AITRIOS IMX500 sensor, as well as an NSP processor. And we have like a low maintenance design mindset in mind. make it very reliable, and it's able to update the AI model and the software firmware over the air through network. So, and it's a low power consumption because thanks to this device, it has a neural network built-in. All the models is loaded in this tiny device. Yeah.
Cool.
Next one. Yeah, this is one use case. The camera is mounted on a street light pole and point out to the street. It can be used for pedestrian detection. For example, the video we showed just now. On the left-hand side, it's the capability of the camera. You can see one particular side is for installation app server. This is like tackle the installation issue. When you install this camera, you can view the real-time image, the footprint, and you can point to the camera to the area you are interested in. You can set up the area you want to detect. So everything can be everything can be done locally. You don't have to like go to the cloud and coming back and forth. So this is one thing I want to mention.
By the way, a question from Mark on I don't know if this is possible yet, but tracking emissions data. I don't know if you can do that visually, or is there like there's all kinds of really cool sensors out there, you know?
Right.
But I'm not sure if that's something.
This is a video-based system. So what you can see is a video. Of course, you can tune the video to be the best performance, but the emission may be a challenge for this. We may be adding like an extra sensor to detect that. Right.
By the way, just want to throw one more question in there from Alex. Minimum amount of light to use the camera. So can this operate in complete darkness, or does it require some ambient light, or what's the roughly kind of?
Right. With these advanced technologies, and Sony sensor is very famous on its performance. So we tested at night under the street. Even the street light is off. I measure it's like 0.1 lux. It's still
pretty dark.
Very dark.
Good. That's awesome. Good stuff.
Yeah, here's the highlight of this feature to tackle the challenges. Actually, we already gone through most of this. Yeah, I will quickly skip it. And this is the spec. I want to point out that it's very flexible. Even the lens, we can provide different kind of field of view lens, and of the model as well. You can fit a lot of different kind of model for different applications. And the connectivity is we provide like LTE, Wi-Fi, Ethernet, and input-output alarm. Yeah, there's a bunch of connectivities.
Does it have like an M.2 module to do things like LoRaWAN or alternative like radio connectors and stuff?
Yeah, it has like we can put add-on cards inside the camera, and then to connect to different kind of protocol.
Pretty cool.
I have a question. So I'm not too familiar with how the cell carriers structure their pricing plans, but is there any benefit to scheduling the time when the download and upload of data occurs, like maybe at 2 a.m. in the morning?
No, it's just based on the data size mostly, and you can choose like a very low data bus, and its cost is very, very minimal.
Awesome. By the way, our party is going to end in about a minute, so I guess people can go to Leopard Imaging to get more details on the camera. But I do want to thank everyone here. We're going to have this archived, on YouTube and LinkedIn, and certainly you can contact you at Sony. There's a Sony link we'll provide, and there's lots of information out there we'll provide. So I really appreciate everyone joining us today. Hopefully we learned a little bit. I did. And maybe this is a blueprint for folks out there to use in their own cities as well. So thanks, everyone. Really appreciate it.